So the last topic of this class is mobility. Now this video will be the last video of this class. Okay, we talk about some advanced topics. Okay, the question is, what is mobility? So from a network perspective, okay, if you have a PC and you connect your PC to a Ethernet network, because you have a one line, right? So basically you cannot move. Of course, if you have a very long Ethernet cable, you can move a little bit, right? But we don't call it mobility. If you want to change your Ethernet cable, and you have to disconnect it, right? Or you have to power down while moving. So that is no mobility. Okay. The second part right here is device can move within same access point in one provided network. It's very similar to your home network. Okay, you can use your laptop, your cell phone in your home network using Wi-Fi, right? So you have a single AP. It's under one provider network. For example, ADSL or cable network. But you cannot go far away, right? Too much, because a BSS has its service range. But you can still move. But basically, when you move, you have the same MAC address, you have the same AP associated with, you have the same IP address, your socket will not be broken. Your video streaming is very smooth, right? Because although you use Wi-Fi, you can move around, but basically this connection is not disconnected from the perspective of network, but you have some certain of mobility, right? But we need even more high mobility. So at the right hand side, we are interested in this. Okay, device moves among APs in one provider network. It's very similar to campus network. In our campus, we have several AP, right, access point, and they have same SSID, which is NCCU, right? Wi-Fi. But they have different BSS ID, of course, because they have different MAC address, right? But when you move from one classroom to another classroom, okay, I say maybe, okay, maybe those AP are under same router, like this. Right? So you can move from one BSS to another BSS. But at this moment, you simply just associate to another layer 2 device. But your layer 3 IP address should be the same because they are under the same router. Right? So there's another level of mobility. Your layer 2 will switch to another AP, but your layer 3 is still the same, right? Let's take a look at the last part. Device moves among multiple providers' network while maintaining ongoing connection. That means when you move from one cellular tower of your home network to another cellular tower of a visit network. If that means you move from one, for example, you move from AT&T tower to T-Mobile tower. If we have a very high mobility, maybe your IP address is still the same. It is incredible, right? If your IP address is still the same, then your layer 4 socket will not be broken. And your layer 7, for example, you are watching YouTube or Netflix, the service, the layer 7 application is still worked smoothly. because you don't change your IP address, so your socket is not broken, so your application still works. That is a very high level of mobility. So we will introduce there several different mechanisms. How do we achieve such kind of high mobility? Okay, we will skip this part because it will introduce some old approaches, but actually we use the second approach, which is that end system handle it. Okay, we have two different mechanisms. So we simply just skip this one. We take a look at this view graph, which is more simpler. Okay, so that is the scenario we have to introduce, right? We have a home network, we have a visit network, we have two different network. Okay, you pay your home network, right? Service plan with a cellular provider, for example, Horizon, Orange, AT&T, T-Mobile, something like that. Your home network HSS and will store the identification and service information about your subscription, right? And visit network, okay, any network other than your home network, the service agreement with other network to provide access to visit mobile. So your home network and the visit network, they should have some contract to allow you to do such kind of roaming. Okay, so on the contrary, in Wi-Fi there's no notion of global home. You simply just move from one access point to another access point. Okay, if the access point is operated by the other ISP, for example, if you are using campus network, NCCU campus network, and someday you visit another university, and another university still provide Wi-Fi service, and you move from NCCU Wi-Fi to, for example, another university Wi-Fi. The simplest way is to disconnect your Wi-Fi and to attach to associate with new Wi-Fi in other university, right? But there's always some authentication problem. So let's take a look at credential from ISP stored on device with user. ISP may have nation or international presence. Okay, since we have different network, so you have to get the authentication on the other campus network, right? So it's really depend on your university and the other university if they have certain agreement to allow you to use some password or some ID to access the AP at your visit Wi-Fi. Okay, and of course in Taiwan, most of the university indeed has such kind of agreement. So you have to go to your computer center and request a roaming ID and roaming password, so they can use the Wi-Fi in other university. Okay, that is just explanation. Okay, we'll go back to the 4G and 5G. Okay, so you have a home network, you have a visit network. Okay, the home network IP address is 128.119/16. The visit network has another IP address, another subnet 79.129/16. Okay, and currently originally you have a permit IP, okay, in your home network, and you try to move to another visit network. Okay, and the correspondent right here is that for example, you are watching YouTube or Netflix movie, okay, and you keep moving moving, and then we'll talk about if you move to your visit network, how your Netflix or YouTube will keep you still working. You don't have to disconnect. You don't have to disconnect your Wi-Fi or your cellular. You don't have to change your IP address and how it works. Okay, while you are still watching the YouTube movie. Okay, The first thing is that if you move to your to the visit network, the first, mobile should associate with visit mobile manager, right? And then the mobile manager should register the mobile, that means your cellular phone, so location with the home address. So your home access, your edge access need to keep the record up to dated where you are, which node B or which cellular tower you use, which visit network you are in. Basically, the mobile manager MM need to report all those information to your home HSS. Okay, so then both sides, the home network and visit network, they know where you are and where is your location. Okay, so that is the first step. Okay, and think about one thing. Okay, that is the one of the approach called indirect routing. Okay, so after you do such kind of registration, okay, so for the correspondent, for example, that is a YouTube. That is a YouTube server. Okay, when the YouTube server send the video to your permanent IP address, but you are not there already because you moved to the visit network and you register to the MM and your home HSS, but the video content still sent by the correspondent to your home network gateway. Okay, so correspondent use home address as Telegram destination IP address, but your home gateway knows you are not there already. So step number 2, the home gateway receive the diagram and forward, which means tunnel the diagram to remote gateway. So that's step number 2. So step number 3, the visit network gateway will receive such kind of content, and then because the visit network gateway and the MM knows where you are, so the visit gateway router will forward the content to your mobile. So take a look at this when you in the visit network, you should obtain a IP address in your visit network. No matter it is a public IP address, for example, give the visit network gateway gives you 79.129 public IP address, or they give you a private IP address, because visit network gateway can act as a NAT server, so you can get an NAT IP address. No matter what, the visit network gateway know where you are and what is your current IP, so they can deliver the content to your current IP address, which is step number 3. Okay, but when you send when your user agent want to send for example a TCP acknowledgement out, okay, right here in this page, that is indirect routing, right? So 4A is visit gateway router forward your reply, for example, your TCP acknowledgement, to correspondent via home network. So that is indirect. 4A itself is an indirect. Or 4B, the visit network gateway will send your acknowledgement directly to correspondent. So this acknowledgement will not go back to your home network. So that is direct way. Okay, so in this page, mobility with indirect routing means the correspondent need to send your content to your home agent, home network gateway. So step number 1 and 2, there's a triangle, right? Step number 1 and 2, that is indirect gateway. That is for the content delivered from your correspondent. Okay? That is indirect. But your acknowledgement, which is step number 4, it can be indirect for A or direct for B. I'll make sure you understand that. Your content from correspondent is definitely indirect, but your acknowledgement can be indirect as for A or can be direct as for B. Okay, make sure you understand that. Okay. But for the indirect routing, there's always a triangle, right, between correspondent and you and your home network. So that is inefficient, apparently, right? So, but for such kind of design, the ongoing connection, the blue word sentence, the ongoing TCP connection between correspondent and the mobile can be maintained, because the correspondent never knows you are not in your home network, right? Because only the gateway knows you are not in your home network. But the correspondent does not care. The correspondent only need to send the content to your home network. That is okay for the indirect routing, right? So that is another approach called direct routing. That means when the correspondent try to deliver the content, step number 1, correspondent content home addresses and get mobiles visit network. So correspondent knows you are not in your home network. So the correspondent will send the content directly to the visit network gateway, and the visit network gateway will deliver it to you by step number 4. So in mobility with direct gateway, okay, that is another approach compared to the previous one, right? Correspondent need to involve in such kind of direct routing. So basically, it is more efficiently, but that is not transparent to a correspondent. So basically, we will not take this approach because YouTube server should not care where you are to send its packet to the visit gateway. It is too complex for router. For YouTube server. So basically, we will not take this approach. Okay. So the next one is when you move between different tower. Okay, there are some things need to do. Okay, first one is you have to associate with the base station, right? As we mentioned before, and when you associate with the tower, you need to provide your IMSI to identify yourself. What is your home network, right? So even when you in a visit network, you still need to do such kind of association. The tower at the visit network, they will do authentication with your MME and your home HSSS to make sure you can actually associate with the visit network tower. Right? So step number 2, at the control plane, they have to do such kind of configuration to check out your authentication. So number 3, after they do every configuration, okay, step number 3, MME config the forward tunnel from mobile, right? So visit home network establish tunnel from home gateway to mobile. So there will be, as we mentioned before, in LTE, there will be 2 tunnels, right? One tunnel is for E node B to S gateway. The other is from S gateway to P gateway, right? So originally, when you at your home, so that's UE, right? So there will be E node B, right? There will be S gateway. So there, if you are at your home network, there will be, of course, there's wireless communication right here, right? So there will be one tunnel between here and here, two tunnels, right? But in when you do roaming, okay, there should be the S gateway right here. So there should be a tunnel right here and another tunnel right here. Again, from your UE to your visit S gateway, and to your visit gateway to your home P gateway. Again, we have two tunnels, but in your home network, you have the two green tunnels. But in your when you add a visit network, the two tunnel will be between UE and visit S gateway and visit gateway to home P gateway. Okay, that is how it works. Okay, and of course you can still do handover at the visit network. Okay, so mobile device can change its point of attachment to visit network. Of course, you can do so. And of course, corresponding MME and HSS, they also need to send a lot of packet to notify each other you change your tower. Okay. So again, we can skip this one because we will not talk about authentication and encryption things in our class. Okay. So again, that is how what I mentioned before. We have two tunnels between S gateway and P gateway. So that is why roaming is so expensive, because all of your traffic will pass through visit home network's S gateway. The S gateway will keep tracking how many packet, how many voice packet, how many data packet has been sent, right? And all the traffic will go back to the P gateway through the internet. So that is why roaming is so expensive. And all your traffic will, again, for example, you're watching YouTube. Your YouTube traffic will go back to the home gateway, P gateway first, and then will tunnel back to the visit network. So the resources is a little bit wasted, right? So that's why roaming is so expensive. And all the tunnels still use the GTP, which is GPRS tunneling protocol, and it captured by GTP inside the UDP, as we introduced before. Okay. That is another topic. That is if you hand over between different towers. So that is how it works. But basically, it is still very simple. Okay. Step number one, we have a source base station and target base station. So we switch from source tower to target tower. So if you want to do, if you keep moving from source tower and approach target tower, because they keep monitoring your signal to noise strength, so the source tower knows you are leaving and you are about to enter the BSS of the target BS. So the current, your source BS will select target BS and send handover request message to the target BS. So both BS knows you will leave source and approach the target BS. Okay, so after the target BS receive the handover request message from the source BS, the target BS will allocate necessary resources, including time slot, including what frequency you use, including maybe you use code division, any resources, and will send a response back to the source BS, okay, which is a handover request. Okay, let's spend step number 2. So now both source and the target BSS knows you are about to do handover. Okay, step number 3, source bus inform mobile of new BS. So your BS source BS will inform your cell phone. So, okay, your signal strength is too bad. You need to hand over to a new cellular tower. So a mobile can now send via new BS because it associated with the new BS. And now, after you switch to a new BS, right? So for the mobile, the handover looks complete. But actually, you know, when you, for example, when you are if you are watching live streaming video, so live stream video keeps be forwarded to the source BS. But when you move to the new target, right? So I think right here, right here, there were several, frames, several packets in this tunnel, right? But when you move to new target BS, the tunnel, because you leave that, so you leave your original source BS. So source BS stops sending diagram to mobile. Instead, it forward the ongoing packet to new BS. So the new BS will later forward the ongoing packet, ongoing diagram to your UE. Okay, and then step number 5. The target BS inform MME and HSS that you are under new BSS. So the MME will instruct S gateway. Okay, so this is S gateway. So originally, we have 2 tunnel right here, right? The blue ones. But after the S gateway is informed by the MME, the S gateway will establish a new tunnel from S gateway to a new target BSS. So all the following movie traffic will be directly tunneled to the new BSS. So there will be a certain period of time your packet will be delivered by the source BS and forward to the target BS. Then after that, S gateway create a new channel, new tunnel, right? So the new packet will directly go to the green channel, green tunnel. So that is okay. So number 6, target BS back to source BS. Handover complete. Source BS can release the resources and mobile diagram now flow through the new tunnel from target BS to SGW. Okay, so that is how mobility works. But again, like IPv6, mobility is designed and it has a very nice design. But mobile IP architecture has invented in more than 20 years ago. But long before smartphone 4G support internet protocol did not see what deployment and use. Okay, because currently Wi-Fi is good enough. So think about one thing. When you move from one Wi-Fi access point to another, it is not a big deal if their two Wi-Fi connection broken, right? If you want to move to another access point, you can simply just associate with new IP and associate with new AP and get new IPs. And as you know, even if the socket is broken, it is fine because your Layer 7 application can simply just easily set up a new socket and continue the application, continue to render the movie on your screen. You don't even have to know your Layer 2 is broken you change your AP, you have a new IP address, your socket is broken. You don't have to you don't have to notice that. So currently, it is good enough for you to watch such kind of streaming applications, because they are aware of the layer 2 connection can be broken. But it's okay. After you get a new IP, you simply just set up a new socket. That's good enough. So currently, only in server network, we can do such kind of handover, and you can still have your application work properly. And for no mobile IP, which means if you move to your visit network, can you use your permanent IP like this one? That means when you move to your to the new visit network, can you still use permanent IP address? And of course, yes. In direct route and direct route and indirect route, we show you how to do so. But basically, most of the network does not implement such kind of mobility IP. You cannot use your permanent IP in your visit network. The more convenient way is that you access your visit network and get a new IP from your visit network. You don't have to use your permanent IP. And then the structure is more simpler, more easier. So mobile IP is not that popular. I mean, basically no one, as I know, no one use mobile IP in current 4G or 5G network. Okay, so that is of the classes we introduced to you in this course. Okay, so we have Wi-Fi. We introduced wireless. We have Wi-Fi. We have 4G, 5G. We discussed the mobility problems, but currently we don't use mobility quite often. Okay, that is all the things, and make sure you go to the final next week. Okay, so that is all the things. Make sure you go to the final exam. You hand in all the homeworks. Okay, make sure you check out the class website. Okay, that's it.